Hey, everybody, welcome back to another episode of the Machine Shop Growth Podcast, Operations Edition. And so, last time Mike and I were on together, we talked kind of a little bit about getting the second shift, maybe doing a little lights out kind of thing, opposed to a second shift, doing some unattended machining and things like that. And so I thought today I might expand a little bit on some of that, on some of the different processes and things that really need to put in place. Because, like I said before, we kind of covered 10,000, 20,000 foot view, 30,000, whatever you want to call it, of what you need to do. But like, what does it actually mean? What do I mean by you need to refine your process to be, effective on a second shift? You need to um, essentially design a process that basically can run with nobody there. And then you mitigate all your risks. Well, how do you do that? Right? Like what kind of things should you be thinking about when you're considering, you know, preparing for that, getting ready to make that move and that leap. So, but yeah, that's kind of what I want to talk about a little bit today is, it's kind of those things, starting, everything is, I hate this word, but I swear every time I go on LinkedIn, there's like three words that make me sick because I hear it all the time: culture, scale, margin. That's all anybody says. I mean, all these guys, these manufluencers or whatever, that's all they say. They just repeat the same three words: margin, scale, culture. It drives me insane. But I'm gonna have to say one right now, and that's scale, right? Okay, so scaling doesn't just apply to, it's just a business term. It's not, a term that these guys with business degrees walk around regurgitating, thinking, "No, I'm smart if I say this," right? It's a real thing, and it applies to more than just revenue. It applies to your process, right? You start here, and there's graduations along the way, and you scale yourself up as you go from an operations perspective, just as you do a financial perspective and whatever else, right? Um, so yeah, there's levels to it. So we'll start like right at the bottom. I don't want to call it the bottom because, you know, I I don't think that there's anything wrong with owning a machine shop that, hey, I don't want to be a $10 million shop. I want to just make enough money to make a decent living. And um, I don't want to work for myself because I've got the ingenuity and the guts to do it on my own. Good. Do that. So that's not, I won't say the bottom, but we'll start at the lower end of the scale, right? Of where we want to be for what we want to achieve, which is ultimately, in this episode, we're talking about lights out machining, automated machining, unattended machining, or second shift type thing. So, okay. So starting at the typical job shop, job comes in the door. We have no machines, I'm sorry, we have no tools loaded in the machine. We are opening this part for the first time. Maybe, in some cases, maybe we don't even have CAM. Maybe we're programming this thing by hand by a G&M code. I'm not going to go that far back. We're going to just assume we have a CAM software. Um, so we're starting right from scratch. This is a brand new part. We've never done anything like this before. We've never seen something like this before. So everything is unique. Maybe we have a vice in the machine and it's trammed in, ready to go. But bringing the part in, we're ordering material, we're programming it like we've never made a part like this before. We get it programmed, we get it to the machine, we're loading every tool like we've never used a 1/2 inch M mill before. We've never used a 3-inch face mill before. Everything just starts as if we've never done anything before. Okay, so we get the part made, we inspect it like we've never inspected a part before. Um, you know, all these things, nothing's prepared. It's all just like, oh, wow, we've never done this before. Okay. So that's like, and it's not to say that, I'm bashing on that, right? I'm not hating on that at all. Um, again, there's scales to it, right? Like when you very first get started, when you're a young shop or whatever, process doesn't matter so much. It's getting parts out the door, right? You need cash. Cash flow is important. I'm seeing a lot, there's a lot of younger people that are starting shops that they do the opposite. They think more on process. And there's a lot of people that just go crazy over that. And that's great for them. And it's a great way to do it. The reality is they don't have families, they don't have kids in most circumstances, right? They're single, you know, who don't know their living situation, of course. And this doesn't apply to everybody, but a lot of people are single. I mean, when my dad started his job, he had 4 kids, a house, a family. Like I don't have time to sit and, you know, perfect all this stuff. I've got to keep turning over cash or I'm not going to feed my family. So, a little perspective there, right? Like you're not wrong for doing it that way. You're wrong for doing it that way forever. There's a time and a place. Like you start, where you start, and then you have to build on that. If you're not building or growing, you're slowly dying. I mean, that is the truth, right? Like you can't necessarily say I'm never going to do this or I'm never going to do anything differently because the world changes. I mean, I remember when I first started, I was cranking handles on Bridgeports, horizontal mills, blades, everything. We had no CNC, and if I said I'm never doing anything else, I'd be without a job. Yeah, I mean, truthfully, it's a pretty tight market right now because there's not much of it out there. So okay, so that's the floor, right? That's just getting started. Okay. So I would say, when you're trying to step toward that automated slash unattended slash lights out, um, maybe second shift type thing, the first thing you got to understand, every part is not a new part. Now, well, we're low volume, high mix. Cool. I don't care. I've heard so many times, well, that doesn't really work for us because we never make the same part twice. I don't care. The rules of manufacturing don't state this only works for high volume automotive manufacturing. Nope. Rules of manufacturing are the rules of manufacturing, period. I don't care if you make 1 to 1 million. They're the same. Now, do you implement certain things differently if you're making 1 million? Yes. Burst 100? Absolutely. Or, burst 1? Absolutely. Yeah, we're not going to go buy, you know, automotive, right? When they're making engine blocks, they'll have, you know, 20 machines in a line that makes this one engine block, right? And um, so they'll do a certain op of this machine and they'll move it to the next. They'll do a next op of that machine. And it improves their throughput and their flow. Okay. So then that's really why they do it. When you're making 1 million of something, if you can save tool changes, you just save millions of dollars, right? Um, so, you know, yeah, of course, we're not going to do that for a single piece. I'm sorry, a one piece order, right? And go back to the automotive thing. It's single piece flow, right? Every time you hit a green button, a part comes out. Done. Yeah, this is single piece opposed to batch production, which we can get into that at a later date. But um, yeah, so it's not the same. However, we can still apply Lean, Six Sigma type concepts and principles, 5S, all those things, 6S, I think we call it now, to our process. Okay. So if I want to reduce waste, and wasted time is a few different areas, but the biggest one to me, the fastest time or money saver is redundancy. And this, I've seen this in so many shops. We finish a job. right? We made this part, we finish it. All right, take all the tools out, get all the tools out of holders, put everything away. For what? Why? Okay, because we're making another part. It's totally different next. Okay, let me ask you this: what material is it? Aluminum. Did you just get done machining aluminum? Well, yeah. Okay, well then most of your stuff's probably already there. You got to face it? Yeah. You got to drill it? Yeah. You got to machine the profile? Yeah. How about an edge break? Yeah, I got to do that too. I just listed like 5 tools you need to leave in the machine. You need a spot drill. You need a face mill. You need an end mill. You need a chamfer tool. I mean, this thought that everything is different is so wrong. Stop thinking of a part by its number. Start thinking about a part by its operations. Start thinking about a part by how you have to make it. I don't care about the part number. That is all irrelevant. If I'm putting a part into a mill, there is a highly, highly likely chance that I am facing, milling, drilling, chamfering. 4 right there. And it'd be a 5th tool because you're going to need a rough and finish, right? On your profiles. Now, I mean, I've lived and died by, I have 10 machines, I have 10 tools. I leave in a machine all the time, no matter what. My face mill in tool 1. Tool 2 is either a 3/4 inch end mill or 3/4 inch high feed. I alternate those two. Tool 3 is a 1/2 inch rougher. Tool 4 is a 1/2 inch finisher. Tool 5 is 3/8 rougher. Tool 6 is a 3/8 finisher. Tool 7 is a 1/4 inch end mill. Tool 8 is a 3/16 end mill. Tool 9 is a 1/2 inch chamfer. Tool 10 is a spot drill. Did you notice how I can just rattle those off? Because I've been doing it that way for over a decade. Because I know I'm going to use those tools on almost every part I make, every single one of them. Standardizing your tooling is huge. If you can, I mean, I've built tool lists to where I've got 100+ tools, and all those tools are in holders. They're in a cart with a vinyl label on the cart that tells you what they all are, what number they are, and then I technically don't even have to touch them off. Once I touch them off, they're in there. If I got to switch it out, put it back in. If it's in that cart, I know it's been touched off. I just put it back in the machine, hit go. Why bother? You know? So there, is another proofing that you can do. Is like, okay, now I don't have to, hope that you're removing a step. You see, that's what a lot of it's not foolproofing. I don't like to say foolproofing or anything like that. It's just proofing, I guess. You're preventing mistakes by removing the responsibility or the potential for them. We'll call it that way. We're preventing mistakes by removing the potential for the mistake to even happen. Okay. So standardizing your tool list is huge. And it's not even just going to help your setup time and everything. It's going to reduce errors from the programming room to the floor because everybody's playing by the same sheet of music. I mean, that's really the truth. If I got a standard tool list, you can't standardize everything. Don't get me wrong. You can't say like, these are the only tools we're ever going to use because, I might get a part that's got a 1032 tap in it. And I get a part tomorrow that's got a 1032 STI tap in it. Well, crap. If you're tapping, that's a new tap, right? I guess you could say, the hell with it, on thread mill and everything. And then you could be even more standardized on your tapping, but that's a pretty slow way to go. So it's a lot faster to tap them. I mean, I've worked in shops that we only did a lot of titanium and Inconel. We thread milled only. We didn't tap anything. But anyway, yeah. So you standardize your tool list, and now everybody is on the same page of what this is, what these tools are. You don't have somebody going and grabbing tools out of a cabinet like, oh, this is a 1/2 inch end mill, I think. And maybe you've got a program for a 1/2 inch 7 flute. They go put a 1/2 inch 4 flute in there. Yikes. That's a problem. You know, um, maybe you got a lesser experienced guy and they put a 3 fluid in and you're running Inconel. That's a serious problem. That's not going to make it very long, right? So again, we're proofing. We are preventing mistakes from being made by eliminating the choices, the decisions, right? It's all a standard list. Okay, so that would be my next step up from that is like again, stop treating a part or stop pretending a part is different because it has a different number. It's not. It's I mean, let's think about a lathe. You know, any part that goes into a lathe, what do you got to do? Turn, face, probably drill, maybe groove, thread, turn, face, drill, groove, thread. It's 5 tools out of your 12 on a turret. Put them in there. Tool one, OD roughing tool. Tool two, OD finishing tool. Those two should never, ever leave your turret under any circumstances. There's no reason for that. I mean, unless you're running turn ground pallet shaft and all you're doing is internal work, which pretty damn unlikely. Those should never ever leave. Boring bars, it's a little bit tougher because maybe you get some really small bores, maybe you get some really big bores. You know, I get that one. But you should still have two dedicated uh stations for those tools and just switch your sleeves. I mean, at least then you're not like, oh man, I got to change blocks to this spot, that spot. Stop tearing your turret down. Stop wasting your time. Dedicate them. This is where it's staying. We're just going to move the sleeves in and out. Maybe you got Capto or whatever, even better. Super easy stuff. You know, the rest of them, they make they're called. I've heard them always called Manchester, which for whatever reason I've seen that on tooling websites too. The dog bone style of grooving inserts, right? Mitsubishi, Iskar, several different manufacturers make the blade style holders that you can bolt the what do you call it? The insert basically. There's a holder you can bolt onto the side of the stick, and your insert goes into that, and they're interchangeable, right? So if I want to groove, I want to thread, it's just a change of an insert, and so that way you're not taking tools in and out again. It's like standardize and modularity, man. If you are not pushing modularity in 2026, holy shit, you're hurting yourself. And it's not even you're just working too hard. I'll say that. I mean, I'll just be honest with you. You're working too hard. Um, is it a little bit costly? Yes, more expensive than just buying a standard old top-notch groover. But again, like, so we just had this actually at Quick Tech. We're making some stainless pipes. We're doing a pipe thread and some stainless, and I said, well, go ahead and turn it. I mean, can I can program a lathe, I can run a lathe, I can do all that. By trade, I'm a mill guy for sure. So, I've been focusing a lot more on the mill stuff over there. And then we had that come up and I was like, all right, go for it. Here you go. Use the program, do your thing. And he's like, well, we keep blowing up these thread inserts. Well, what are you using? And he's like, well, we're using this yellow insert. And I looked at it, I was like, oh, it's a top notch. Good Lord. And so I looked and I wasn't very familiar, but I looked for some top notch with a chip breaker. Not very many options out there, So again, like you get into stainless and you start, curling that chip up and you don't have anything to break it, you're going to build up heat and you're going to smoke that insert just like we did. Especially because I mean it's a deep thread. So anyway, like that's all that is to say, you gotta keep up a little bit because the technological improvements they have made in material removal are insane. I mean, geez, over the last 20 years since I've been doing this. I mean, I started with high-speed steel end mills. If we got carbide, it was like gold. I mean, I'll never forget my dad's like, oh, oof, don't break this. This thing's expensive. And it's like now, whatever, throw it away. Who cares? I mean, it's such a different commodity now than it was then. Like it was a big deal. If you and now, of course, we're always using carbide and lathes, but like on the mill, if you had a carbide end mill, it was like, hey, keep that one in your box. You don't want to stick that back in the drawer and have somebody take it. That's where it's good. It's great. It was great to have it, and I mean, I've still got a toolbox full of high speed steel end mills out in my garage that I probably should get rid of, but I haven't yet. So anyway, standardize your parts and modularity. You know, get into those tools that you can leave the same stick in there or whatever, and just change blades. Maybe you got some of the screw tip style. They all make them. Ingersoll, Iscar, Tungaloy, Mitsubishi. They all make the shank that you screw in like an end mill tip or a spot drill, chamfer mill, thread mill, whatever. They're awesome. Best part is, and if you call them different tool numbers, maybe you got a tool number for a spot drill or whatever, a thread mill, and they're different. You screw that tip in, you're within like less than 2 thousandths on your tool height. So that part's all great. Okay, so we got through that. We're going to standardize our tooling, right? We're removing variable number one. Okay, so let's move on to some more variables. Is how do we standardize our workflow? I would say the next move on that, and it's part of standardizing your tooling, but your next move is standardizing your work holding. I spent a while where every piece of material that came into the shop straight to dovetail every single time, no matter what. Now, sometimes there would be different patterns cut into the dovetail. Sometimes some dovetails would be deeper than others, depending on how big the part was, all that kind of thing. But the point was, every piece of material got dovetailed that was going to go in a machine, no matter what. We put it in a dovetail vise to run it. So, when you start thinking about what do I have guys do on second shift, dovetail is a pretty non-critical function, right? There's nothing to affect in form, fit, and function of the part. There you go. I mean, I had some tie parts that literally took like an hour and 30 minutes to dovetail because they were big and the dovetail got super relieved and there were pockets in it and all sorts. And maybe there was a pre-rough op on the back under the dovetail. But yeah, every single part. There would be a few exceptions here and there, but that was our standard procedure. Anything other than that was a deviation. But the standard was dovetail it all. So again, now let me rewind a little bit to proofing. We're removing mistakes by eliminating variables here. Okay, so how many times, and I know I do it when I'm programming, I'll make setup sheets and I'll say, hey, put this in a Kirk vise, hold it along these dimensions, hold it in the vise by a 1/4 inch or less. Okay. Well, whoops. We held it in the vise by 3/8. Whoops. We mowed our vise jaws. So when we put the parallels in that should be a 1/4 inch, maybe we're only holding it by 3/16 now. We don't pay any attention to that because we're not looking at that. And now we slam an end mill into the vise. Whoops. You said hold it by a 1/2 inch and no less. I held it by a 1/4 and I just ripped the part out and threw it across the shop. These are just some examples of things that could happen. or maybe you need to hold it by more. Somebody holds it by an eighth inch and they flex the part or whatever. The list never would stop. There's all sorts of it. Okay, so it's gone. There's no variable anymore. In all the dovetail vices, what I would always do is I would make tabs, and like fifth axis vices especially, they've got tapped holes on the sides of the vices, and I would just make some tabs that come up and cover the side of the vice. And when I would dovetail, um, I would cut slots for those tabs to sit. So let me say this lightly: you should not be able to misload a part, but you can. I the unattended thing, right? I had a pretty long cycle time part. It was an aluminum, and we had several of them to make. And so I had a guy, a younger, my apprentice, um, go in on the weekends or the evenings or whatever, and he would load the parts, keep the machine running, right? And it was a good deal. We would always pay him 2, 3 hours of overtime just to show up for 20 minutes and load a part and go home. So it was a sweet deal for him. But somehow he managed to it was aluminum part, right? But those good old tabs I put on the sides to capture the part managed to crush those right through a dovetail. And I came in the next day and mill's blown up, and I'm like, what exactly happened? I don't know. I put it in just like you said. I'm like, no, you didn't. And yeah, I opened the vise up and I'm like, how, how do you do this? Oh, I don't know. And so anyway, yeah, funny story, but so I can't say you're eliminating all variables, but you're eliminating as many as you can control, right? Um, so work holding is a big one, right? We don't want to give we don't want to give too many options, or too many areas to make mistakes. And again, when we streamline our tool holding and our work holding, we eliminate variables not only from production, we eliminate variables from programming. Okay, so where's your other where's your other issue going to come on a second shift? You got to put your best product out there on the floor, or in lights out or whatever. Like if I've got okay, if I'm the owner of a $250,000 piece of equipment, I'm not letting just anybody program that thing to run when nobody's here, because I need to trust that um, we're not going to be spending $25,000 tomorrow to replace a spindle. Or worse, I mean, I used to run titanium lights out all the time. It'll burn your building down straight to the ground if you're wrong. Um, yeah, I mean, it's risky. And I remember several times it's like, ugh, I wouldn't sleep. I would literally lay there several times. Even I said, "Oh man, I think I screwed up," and I would drive back down to the shop. And of course, I'd get there and be like, "No, I just sat and thought about it too long." Um, but yeah, it's stressful. Um, which is why you need to have somebody that knows what they're doing, right? Now, again, I go back to this, even for programming, eliminating variables, right? So now we've standardized our tools, we standardize our work holding. Now, that helps our programming because, you know, you have a set amount of parameters to work within, and you need to make as many things work within these parameters as possible. But mostly we know how we're holding it because we pre-planned that when we went to the dovetail op. There's no, oh, we're gonna make a fixture, right? Geez, how many times have you heard the word? We just got to make a fixture. Nope, this is your fixture, And of course, I mean, again, like this is not stuff that applies 100% of the time, but this should be your majority. Okay. So we standardize that. How do we standardize our programming now? Um, how do we change things to be more streamlined and reduce variables in programming? No mystery, guys. Programmers are getting harder and harder to find every single year. There's less of them out there. The price for a programmer keeps going up if they know what they're doing. Some people like to tell you, I think I saw the former CEO of Autodesk said in 2 years, nobody's going to be programming a CNC machine anymore. He's full of shit. I mean, I don't care. Like, you see this, whatever. Nope, you're wrong. Like, you are so incredibly wrong. The infrastructure's not there. The AI data centers can't be supported. And quite frankly, Mastercam's been around 30, 40 years. I still can't get a working post for every machine that's out there. So you think that AI is just going to somehow come in, do what, we've been unable to do for 30 years and two? You're wrong. You're 100% dead wrong. So if that's your plan, if you think I'm just going to wait it out and have AI take over all my programming in 2 years, you're going to hurt yourself. You're going to hurt yourself bad. There are systems out there that there are some AI functions that you can use to program a very specific group of parts. If you're doing turbine blades, forget it. AI's garbage. Okay. Now, will it be forever? No, probably not. Will it get better? Yeah. Will it eventually take it over? Maybe. But it won't be in 2 years. I promise you with all I've got, that's not going to happen. So anyway, don't hope on that. Don't bet on that. Don't have that be your solution. Start your solution right now. And keep in mind, when you do go to when everything does shift to an AI model, this standardization will help you there. Because, I've been through this with some of the guys that do the AI programming software. And that was my biggest takeaway. If you're not standardized, you have no business doing AI. None. Because it doesn't have any idea what you're using unless you tell it, right? And it can give you like some generic stuff. Like, oh, I'm using a 1/2 inch end mill. Well, we're just going to generic run it at 400 surface feet. And I don't know how many flutes it has, so I don't know what chip load to run it at. Or what inches per minute to run it at based on chip load and all that kind of stuff, right? And some higher performance end mills, they need more chip load. And you got to put the radial chip thing on there. You got to make a lower radial and speed that feed rate up. Or who knows what. You have to define all that to the software, right? So having a master tool list for various materials that you have all that predefined in your tool definition, you're a step ahead when the AI starts, right? So several of the companies I've worked for, like, they could use AI in its current state and have some value come out of it because I standardized all their tool lists. I created them tool libraries for multiple materials, and I entered all that information. So all their stuff's done on the front end, and they just got to plug it into the software, right? So, again, going back, like, this is all things looking forward. We do these standardization steps. It helps us now, and it's going to help us more in the future. But going back to the programming section, or the programming part of this scale up into running unattended and things like that, you've got to eliminate variables because you'd have no idea what you're going to get from a skills perspective. It's you may get somebody really good, you may not. Maybe they take forever to do something, and so you get things done up front. All right, and this is how for our dovetails. we have pre-saved all of our different work holding configurations. If you get a vertical mill, highly recommend slapping a grid plate on that machine. Martin Trunnion makes a really good grid plate on a 2-inch spacing that is awesome. And it's very, very, I think they're fairly priced for the work that goes into it, precision ground, all that kind of stuff. High quality. And reason I say grid plate is because I can position things inside of that machine, different work holding, and I can just say, look, if you're going to use this, slap it in A7. Maybe that's going to be your top right. Your top right post is going to go in A7, something like that. You don't ever have to pick up another work offset ever again. And there's never a question of where something's going to be because it's literally right there. Like we don't have to think about spacing, get your scale out, measure how far. Nope. Don't do that. Just stick it in this grid. Easy, right? So if we're running the vertical, I recommend that. Now, of course, everybody doesn't have that. I got it. So rather than, have your grid plate, maybe you got things bolted to the table. Well, every time you program a part, you need to put your vise in there. You need to put everything in your environment in there. So you can see what's there, what's interference, collisions, all that kind of thing. Running the horizontal mill, I always pre-made all my tombstones, everything. So when I would make a part, I would open my Mastercam file of my tombstone. I would merge my part into there, save it as my part number for the program or whatever. But I didn't have to go reconfigure all my tombstones again every time I started again. It's a new part, not a new process. It's not a new, manufacturing process. It's not just, we're not reinventing the wheel every time we're going. Like the thing keeps spinning. It's not that big of a deal. We make so many times in this industry, we make things so much harder than they need to be. Standardize, copy and paste. Good Lord. As a matter of fact, I got some parts I'm working on for a buddy of mine right now. They make, I don't know, 20 to 25 variations of one part. And they're all pretty varied. They have some very, very different geometries from part to part, but they're basically all the same ops. I export and import toolpaths across every single part. So like op 1, I can program op 1 on every part in about a minute and 30 seconds. Op 2, on similar parts, I can probably program them in under 10 minutes. And I don't know, you're probably talking 40-ish toolpaths total for the whole part. To program that from scratch, if I wasn't interrupted, I'd probably do it in under an hour. But yeah, you see there, right? Like I took, we'll call it 60 minutes. I dropped it down to about 12. Just by, it's a different part number, right? It's different geometry within that part number, but it's the same damn process. So I'm going to use what I've already got and go make the next one and go with the next one faster and faster and faster, right? Think about that. If they got 25 part numbers, it was going to take me an hour each. It's 25 hours. But if I drop that down to 10 minutes for 24 of them, it's 240 minutes. That's 4 hours. Plus the first one is 5. So I went from 25 hours down to 20 or down to 5. I saved 20 hours. We'll call it $150 an hour. 20 hours, that's $3,000. I mean, save $3,000 in a week. That's pretty good for one guy. I mean, you probably covered his salary and most of somebody else, right? So, yeah, those are the kind of things that you'll start seeing, right? And again, I eliminate mistakes because I eliminated mistakes of using different tools, maybe calling a tool a different number, and be like, oh, that one's already in the machine, and whoops, it was tool 7 in this program and tool 24 in the next program. Crap. No, all the tools are still there because I've copy and pasted everything. Operations, tool numbers, tool library, everything. It's all copy and pasted. No big deal. All right. So we've gotten a little bit into standardizing your programming. The other thing you need to do is I've been in a lot of shops that um, they may have 3 different CAM packages. You need one. Um, it hurts, sucks because maybe you got Jim that's been working with you for 30 years and he's used SurfCam 1996 for 20 years or whatever, and he doesn't want to switch. Sorry, Jim, you're going to switch. Um, it doesn't help you any to keep doing that because then what happens when old Jim's not there anymore? And now you got all these legacy programs that are in SurfCam you can't open because now you switch to Mastercam or NX or Esprit or one of the higher end cam packages. And well, I can't open that SurfCam. Now I got to reprogram it because Jim refused to switch. Don't do that. Standardize your cam package. This is what you're using from now on. It's for the better, it's for the best interest of the company. We're not doing this jumping back and forth crap anymore. So, everybody has their own preference. Mastercam's #1 in the world for a reason. Esprit and X, phenomenal. Great software. They're not taking a single thing away from them. They're about double the cost of Mastercam, though. When you're a job shop, small or smaller job shop, those things matter. And the truth be told, NX and Esprit are really only better if you're doing simultaneous 5-axis and mill turn type work, in my opinion. And don't get me wrong, Mastercam will do both of those things. It's just a little more clunky, in my opinion, than using NX or Esprit. And I'm not bashing Mastercam at all. We use Mastercam for, almost 15 years now. Love it. That's actually open on my computer right now. Yeah, it's an excellent software. It's amazing software. Great stuff. We're going to go to the next point here of error proofing. Vericut. If you want to run at night, you want to run unattended, you need Vericut. Because now you're talking digital twin of the machine that this program is going into. Most of your CAM software, Mastercam especially, doesn't actually read the G code. It just posts a video render of the toolpath, essentially. So it doesn't actually read the G code of what the machine's doing. Vericut does. Vericut runs in the computer exactly like it's going to run in the machine. If it crashes in Vericut, it will crash on your machine. You can count on that. Now, a lot of this in Mastercam, if you're doing 3-axis work, generally you can catch your crashes and your mistakes in the Mastercam verify function. Where you will not catch them at is when you start doing multi-axis or in 5-axis type work. And the reason is Mastercam doesn't understand what's rotating, right? If you watch your tool is moving. Well, that's not reality. The rotary is actually rotating, right? Or your platter or whatever. And so it won't catch those things. Vericut will. Very expensive. Very, very expensive. But it's cheaper than a couple spindles. I'll tell you that. If I had to spend 40 grand to get Vericut or right around there, it's an expensive system. But if that meant I could put parts into 10 machines and run them unattended all night when nobody's there, you know how fast I could pay for Vericut? Because I know it's not going to go down. Right? So yeah, you need some way to verify what you're putting out to the shop. You can't live on a hope and a prayer. You need to make sure we're putting out quality to the shop. If you don't put quality out to the shop, you're not going to get quality back. All right. So we may have to do a part 2 on this, but now we standardize our tools, we standardize our work holding, we standardized our programming, and we put a verification software in. Now I want you to see this. 3:30. I got an hour and a half left before I'm going home for the day. I've got some parts programmed ahead. I've got my standard tools in the machine. My work holding is all standardized. It's all in there, and all my parts are dovetailed. Guess what? Oh, and all my programs are verified. I know they're not going to crash. I'm slapping them parts in there. I'm hitting go and I'm going out the door. The machines are running all night or however long. It doesn't matter. I don't care if you run all night. And in fact, I sometimes had day programs and night programs. I'd slow the day program down just a little bit and run it at night just so I knew it would make it through the whole part. Because that's we're money ahead, right? We gain time. And if it doesn't run super efficiently, I don't really care because if I don't have a part behind it to go back in there, it doesn't matter. Now, if I'm running the full pallet pool and I've got 12 pallets sitting there in a full 16 hours of machine time, or maybe I've got 18 hours, damn right, I'm cranking the thing up. We're going to run it efficiently. But, when we're running Inco, tie, stuff like that, like there's no go fast. It's all slow. It's, you just going fast, going less slow. I mean, that's kind of the reality of that stuff. So yeah, you slap them things in there and go home. There's a lot of this automation is the sexy thing. And I don't get me wrong. Again, I'm not bashing on that, but you don't need automation. You don't need automation until you can start running your parts when you're not there. Start there. Again, scale, right? Let's start at unattended machine. Let's start at lights out machining before we think about dropping 80 grand on a robot that's going to sit there and do nothing because you're afraid to let it do its thing. Let's start at lights out and then let's scale up. Okay. Robot, pallet pool, whatever kind of thing you want to talk about. Cool. So we went over a little bit of standardization. If you guys ever have any questions or whatever, feel free to find me on LinkedIn, shoot me a message. I'd be more than happy to talk to anybody about some of these different concepts. It's a scary thing in the prototype job shop type world that people don't want to do it because we're not a production shop. We've never been a production shop. Like people view it as a bad word or whatever. And I'm not telling you you are a production shop, but I'm telling you just because you make low volume, high mix doesn't mean you can't do this stuff and have it have an impact and have it make you more successful because you absolutely can. And not only can you, but it will. If you actually do it, you will become more successful and it will have an impact for you. And I can give you multiple case studies of this, supporting that statement. Because I've done it over and over and over and over and over again. And it never doesn't work. It never doesn't help. It never doesn't make our process better. And again, reduce scrap, reduce errors, all that kind of thing. So, yep, definitely feel free, reach out, talk to me. Mastercam, you guys ever want any help in that? Different ways of looking at things, different ways of doing things, how to speed things up. Find me, shoot me a message. Glad to help you out. So, yep, hope you guys all liked it. Be sure to give us a thumbs up, and I will see you all in a couple weeks. Yeah.
So again, if you have not subscribed to the podcast, please make sure you subscribe to the podcast. Those positive reviews really do fuel us forward, and we'd love a review from you so that we could go and continue to impact people in this amazing industry of machining. So we are so grateful. And again, We are doubling our content this year. No more 2 episodes a month. We're going to 4 episodes a month, and a couple of them will be sales, marketing, growth. The other 2 will be ops, engineering, and the floor. It'll really be the floor, like what happens on the floor, right? We're so grateful for all of you. So make sure that you tune in next week for another episode of Machine Shop Growth Podcast. Thank you all. Have a great week.